This video introduces FR robot usage as Modbus TCP slave station. First, enter coding and create a new program. Open the Modbus TCP settings interface and select Slave Settings. As a Modbus TCP slave, the robot provides 128 cores DO, 128 discrete inputs DI, 64 holding registers, and 64 input registers. Meanwhile, as a slave, the robot also supports the master register to control program start, program stop, and set control box DO. In this video, we use the software Modbus PO to simulate external master devices. Open MBPO, click Connection, and select TCP IP. Enter the robot network port IP. Click OK and return to the web app. The green connection status indicates the success of connection. Now, let's look at the DI and DO operations of Slave Station. Select Modbus command. Click Slave Station, Digital Output. Select DO0, write to for number of registers, and write 1 for the register value. Click Write and Add. Select Numeric Input. Select DI0, write to for number of registers. Assign the readed DI values to variables A, B. Add the query variable instruction and save. Enter MBPO, select MBPO1, click Setup, Read, Write Definition. Set slave ID to 1, select 2 read discrete inputs. The starting address of the 4 registers of the robot is 100. Set address to 100, quantity to 10, click OK. Create MBPO2 and click Stop. Set function code to 1, address to 100, click OK. Set MBPO to address 100, 100 and 1 to on. Return to the robot interface. The DI0 and DI1 values are 1 at present. Run the program, and the DO0 and DO1 values become 1. In the robot program interface, variables A, B are displayed as 1. MBPO1 address 100, 100 and 1 also become 1. Next, we demonstrate the Unsigned AI and AO operations. Select Slave Station, Analog Output. Select AO0, write to for the quantity, write 11, 12 for the values. Select Analog Input, choose I0, write to for the quantity, add. Assign the readed AI values to variables A, B. Add the query variable instruction and save. Modify the MBPO1 settings. Select function code 4. Select MBPO2, function code 3. Write 13 and 14 to MBPO2. Run the program, refresh the Modbus TCP settings. Variables A, B are displayed as 13 and 14. MB port 1 address 100, 101 also become 11 and 12. Next, let's look at the Unsigned AI and AO operations. Select analog output. Select AO16, write to for the number. Write -11, -12 for the values. Select analog input. Select I16, 2 for the number, add. Assign the readed AI values to variables A, B. Add the query variable instruction and save the program. Modify MB port 1, select function code 4. Set address to 110, and click OK. Select MB port 2, set address to 110. Write -13, -14 to MB port 2. Return to the robot interface, where the Unsigned I16 and AI17 are -13, -14. Run the program. At this time, the AO11 and AO12 values become -11 and -12. MB port 1 address 116, 117 become -11 and -12. Next, we demonstrate the float AI and AO operations. Select AO32, write to for the number and -11.5, 12.5 for the values. Select analog input. Select AI32, write to for the number. Assign the readed AI values to variables A, B. Add the query variable instruction and save. Select MB port 1, set the address to 130. Select MB port 1, choose function code 4, set the address to 130, and click OK. Select float inverse under the display option. Apply the same settings to MB port 1. Set the value in MB port 2. Return to the robot interface. At this time, the Unsigned AI32 and AI33 value are 13.5, 14.5. Run the program. The AO32 and AO33 address values become 11.5 and 12.5. MB port 1 address value also changes. Finally, let's look at the usage of the waiting for digital input and waiting for analog input instructions. Choose DI0, set the wait state to true. Set the timeout to 5000. Select waiting for analog input settings. Choose I0. Set wait state to greater than, set value to 1, timeout to 5000. Add the corresponding digital input and analog input instructions. Assign values to variables A and B and add the query instruction. The program logic is to print the variables if the input meets the conditions. within 5 seconds, otherwise, the robot reports an error and stops. Select MB port 1, choose function code 1. Set the address to 100 and click OK. Set address 100 to on. Select MB port 2, choose function code 3. Set the address to 100 and click OK. Write to address 100. Return to the robot interface. At this time, the DI0 and AI0 address values are 1 and 2. Run the program and check the values of variables A and B. That's all about FR robot usage as a Modbus TCP slave station. Thank you for watching.